Okay, the second strategy that we have is factoring and distributing. Okay, so that's kind of two different strategies depending on how it's set up and depending on how it looks. But if you have one that looks like a normal FOIL or factor problem, try to use this strategy. Okay, so example 1 and example 2 here. Example 1 is the one out of the packet. So if you flip to the second page, or if you go to the second page, depending on how yours is set up, it says factoring there. I would also like add a little slash for say factoring or distributing, just because those two strategies kind of work together. Okay, the first one, like the example on there, with the approach that you're going to use, is for this guy. Okay, so I look at this guy, I think about strategy 1, like turn it all into cosines and sines, but it's already all sines and cosines, so that's not really going to help me. But I look at it, and it's a factoring problem. Okay, it's a factoring problem the same as if I had, maybe the problem was 4 minus 4x squared. Very similar problem. And this is kind of the thing, the algebra thing that we're working on. If you can do this, it means you can do this. Okay, this is the basic algebra version. If I like convert this problem into a trig problem, it shouldn't change what I do. Okay, the thoughts and the thinking behind it should be the same. Like if I said, hey, factor this guy, you'd look at it and say, well, these both have a 4 in it, so I'm going to take a 4 out of both. If I take a 4 out of this, I'm going to be left with 1 minus, if I take a 4 out of this, I'm left with x squared. Okay. And then I can look at this piece now and say, hey, can I go any further with it? But the idea is, can I take something out? So that's a type of factoring. Unfoiling is definitely a type of factoring too. But here, just taking out your greatest common factor. Okay. That's the same exact thing we're going to do up here. Okay. I'm going to look at this. It's got two parts. It's got cosine and minus, and it's got cosine times sine squared. It's the exact same problem. I just replaced the 4's with cosines and the x squared with sine squared. So same exact problem. I look at this and I notice, what do these both have in common that I can take out? Well, I can take a cosine out of both of these, just like I took a 4 out of both of these. Okay. So if I do that, I'm going to take a cosine out. If I take a cosine out of here, all that's left is the 1 that holds the place. If I take a cosine out of here, this cosine's going to be gone. I'm just going to have sine squared left. And just like a normal one, like you can take and test it. Like if I distribute this 4 minus 4x squared, yep, worked. Same thing here. If I distribute the cosine minus cosine times sine squared. So same process, kind of cool if you can already start to like match those up and see how those two things are related. Okay. But at the point we're at right now, it doesn't really actually look like we've simplified it at all. Okay, but we can. Okay, and this is what I had said in the very first video, is when you see a problem and you've got squareds in it, if you've got squareds and you've got 1's, it's probably Pythagorean. Okay, so look at the 3 Pythagorean options that you've got. Which one has a 1 and a sine squared in it? Okay, well, this first one has a 1 and a sine squared. So it is this Pythagorean identity that we can use to simplify this. Okay, how exactly can I do that? Well, what I want is I want to have 1 minus sine squared. That's the thing I'm looking to get rid of. So if I come over here, how do I turn this into 1 minus sine squared? Well, I can rearrange it. I can move this over to here. Okay, so this guy right here, if I subtract the sine squared over to the right side, the left side is just going to be cosine squared. And if I subtract this over to the right side is going to be 1 minus sine squared. Okay. So this new rearranged version that I came up with is going to let me simplify and solve this. Because I can look at it and say, okay, well, what is 1 minus sine squared the same as, or what is 1 minus sine squared equal to? Well, looks like 1 minus sine squared is equal to cosine squared. Okay, so I still have this cosine in the front. And then I'm going to replace 1 minus sine squared. I'm going to sub that out and replace it with cosine squared, which is totally fine because, again, we just showed over here they're equal. Just manipulating an equation, which you all have tons of practice in doing throughout this year and throughout your math careers. You might not really realize it yet, but you do this all the time. It's just a different context. Okay, and then some of the basic algebra that you have always done still applies here. Cosine times cosine squared. Well, if you took x times x squared, you'd get x to the third. Okay, so if you take cosine times cosine squared, you should get cosine to the third. Or cosine cubed. It's something I don't think I've pointed out yet, but just a quick explanation. Why, when I have sine squared, cosine cubed, why do I put it here and not on the end? Well, the reason why I do that is if I wrote the cubed or the squared on the end, like that, it would look like the x is cubed instead of the cosine. Okay, so we don't want that. So we always put it after the trig function itself. Okay, so that's a good factoring one. Okay, example 2 is a good distributing one. Okay, you look at this and hopefully your brain automatically jumps to do the same thing it does every time we do algebra stuff ever. You see parentheses, you think multiply, distribute, FOIL, however you think of it. Okay, so we're going to do that. We're just going to take this and distribute it like we normally would. So distribute the 1 to both parts. So you're going to have 1 and then plus secant of theta. So in this one we use theta, it doesn't really matter. Okay, and then I'm going to distribute the negative secant to both parts. So negative secant times 1 is negative secant. And then negative secant times positive secant. Negative times a positive is negative. Secant times secant is secant squared. Yeah, so it's just foiling or distributing like normal. And just like a normal one where it's exactly the same, but one's a positive and one's a negative, when we have opposites like that, the middles always cancel out. Notice here, the middles cancel out. And so I'm just left with 1 minus secant squared. Okay, so it's already simpler. Can we simplify it even more? Okay, well, when I look at it, I have a 1 and I have a square. Anytime I have a 1 and a square, what should pop up in my brain? Well, Pythagorean identities should. Okay, these three. They're all the ones that have 1s and squares. Okay, which one has a 1 and a secant squared in it? Well, that would be this guy right here. Okay, so how do we get what we want? How do we get 1 minus secant squared out of this equation? Well, let's take and let's rearrange it. So to get 1 minus secant squared, I would have to minus the secant squared over to this side. So I'd have 1 minus secant squared. So I'd minus the secant squared over to this side. Okay, to get the tangent out of there, I suppose I'd have to take this tangent and subtract it over to the right side. Okay, so I subtracted this over to the left side, so that's gone. Subtract this over to the right side, and I'm going to have negative tangent squared. And that should look right. So subtracted secant to the left. Secant's now on the left. Subtracted tangent over to the right. So that's now on the right. Okay, which means 1 minus secant squared is the same thing as negative tangent squared. Okay, so 1 minus secant squared is equal to negative tangent squared. So we've got it simplified down to one thing. That's always the goal. Okay, the best thing we can do, get it down to one thing so that from there on out, working with it is as easy as possible. Okay. So that's strategy 2, factoring or distributing.